Alright, we're ready to do another indefinite integral. So once again, there isn't really a whole lot to rewrite in this problem. So what I'm going to go ahead and do is just say, alright, we normally need to pick what's inside the parentheses, and I'm always going to try that first, and if it doesn't work, then we'll talk about other techniques that we can do. But right now, this is going to typically work. We are going to take the derivative of this statement once I've chosen my u, which would be 4x cubed dx. Now let's see how we can start to replace these values. So right now I'll go ahead and replace my u, so I'll write this as u squared. And then if I look at what's left, I have an x cubed and a dx. I only want the x cubed dx, so I'm going to move this 4 to the other side by dividing each side by 4. And that gives me exactly my x cubed dx. So I'll put in here a 1/4 and a du. I'm always going to put that constant out front because I can figure it out later. And what's on top of this is just a 1. So before I take the integral of this, I would go ahead and rewrite it as u to the negative second du. So now I'll take the integral of this, which would be u to the negative first over negative 1. This is an indefinite integral, so I would put plus c. So now I end up with 1/4 times negative 1, which would be negative 1/4. U to the negative first, well, that would put a u on the bottom, plus c. Well, when you multiply 1/4 times a constant, it doesn't change the answer. The only thing else we need to do is replace our u. We've got to remember to replace our u because we were integrating with x's. So my u is equal to 1 plus x to the fourth, so I'll replace that, and then I'll write plus c. I want to point out to you on these, and I'm not going to do a bunch of these examples, but I do want to mention to you that on 30 to 38 even, these are all normal integration, meaning they don't require you to use substitution. So I want to go ahead and show you one of these. Let's go ahead and look at number 30. 30 says x squared plus 1 over 3x squared dx. Now, even though there's a set of parentheses, these do not require substitution because we know how to integrate this. We have an x squared, we can integrate that function, and we have a, this would be a 1/9 x to the negative second, and we know how to integrate that as well. So this would just straight out be, let's integrate this. X to the third over 3 plus 1/9, raise it by 1 and put it over that power, plus c. This would give me 1/3 x cubed plus, I'd have my 1/9, well this would be negative, and then the x would go on the bottom down here, plus c, and that would be my final answer. So when you guys are working through problems, always make sure that you can't just integrate it as normal. You're going to have to recognize substitution. Now, this says solve the differential equation. What that is actually saying is that we really have this dy equals 10x squared over the square root of 1 plus x cubed. And then we'll write our dx over here. What we're really doing is we're integrating both sides when we're solving the differential equation. Well, the integral of dy with respect to y would be y equals, and now we're going to integrate this right-hand side. The right-hand side is not easily integrated, so we're going to have to make a u statement. I'm going to pick what's in the parentheses right here, which would be the 1 plus x cubed. I'll take the derivative of that, and we'll hope that we get what we need. We get a 3x squared dx. Not exactly what I need, but I can work with that. So what I'm going to actually start out by doing is putting this 10 out front. So I move this 10 out front. I have on the bottom of this, I have the square root of u. So I've taken care of this part. And so I only need an x squared dx. Well, I only need the x squared dx, so I'm going to move the 1/3 or the 3 to the other side. So it makes it a 1/3 u, a 1/3 du, x squared dx. So now I can replace my x squared dx with my 1/3, which would make that be 10/3 du. Now I'm left to integrate this, and I'll have to do that on the next video.